So in 5-6, all we're going to do is add and subtract fractions. Okay, that's literally all that's happening. But they're not going to look like great fractions to you. They're actually going to be rational expressions. Okay, so if you know how to add and subtract fractions, you understand everything that we're going to do. We're just going to combine that with our factoring of rational expressions. I'm just going to keep my lightsaber on the entire time. Actually, I'm going to change my lightsaber to be some Darth Vader this time. Perfect. Okay, so key to adding and subtracting fractions is the least common denominator, which is pretty easy with numbers. It gets real hard when you throw in rational expressions, but I will show you how to do it. Okay, so we need to find the least common denominator, then we need to express each term as a fraction with the least common denominator. All right, so do that multiplying stuff like you do with numbers, and then add across the top, keep the bottom the same, and simplify. Okay? Same stuff. Now, just quick review. We're going to fly through these because they're all numbers and monomials, but this is just a review of how to do this stuff. Okay, so when you look at these numbers, right, you got to figure out what the common denominator is. Obviously, this one's real easy. It's 6. I always write it to the left of the problem. You don't have to do this. It just might help you. All right, so because I know that I want my goal to be multiply everything to get to 6. Okay, so I only need to write 6 one time in the denominator, right? Now, I need to multiply some of these, or each of these terms, by something to get 6 as the denominator. So the first one I'm multiplied by 3 over 3, the second one 1 over 1, and the third one 2 over 2, right? So you're multiplying them by 3 over 3 to get 3 over 6, multiplying the second one by 1 over 1 to get 1 over 6, and the last one by 2 over 2 to get minus 2 over 6. Okay, so that's how you add and subtract those fractions. You add them up and you get 2/6, and then you reduce to 1/3. Second one, remember this is 2 over 1. All right, so we need to find the least common denominator there. It's actually going to be 70. Okay, so the first one now multiplied by 70 over 70. Second one, 7 over 7. Third one, 5 over 5. All right, so what we'll get here, I know 70 is my denominator. Now on top, I'm going to get 2 times 70 is 140. Minus 3 times 7 is 21, plus 5 times 5 is 25. Okay, so this becomes 144 over 70, which totally reduces. We just divide by 2, and I know what that is, 72 over 35. Okay, this third one. Now we throw in some variables, but it's not all that different. We're just trying to figure out what the least common denominator is. We've already done the least common multiple with this stuff, so it's the same exact thing. We're just trying to find the least common multiple of the bottom here. So we got 6k and 3k. All our least common multiple for the numbers is going to be 6, and for the variable it's just going to be k. Okay? So for this first one, you guys got to multiply by 1 over 1, or not do anything. And the second one, you got to multiply by 2 over 2 to get 3k. Times 2 is 6k. So we've got a 6k on the bottom. On top, we've got 1 times 5 is 5, minus 4 times 2 is 8, and we've got negative 3 over 6k, which reduces to negative 1 over 2k. Perfect. Number 4. All right, now our least common multiple, or least common denominator for this one, the numbers part is 2, and the variable part is a squared. So our denominator here is going to be 2a squared. So this first one, we just need to multiply by 2 over 2, and the second one, you got to multiply by a over a. So remember that you have to distribute that 2 and distribute that a to everything when you do the multiplication. So we've got 2a minus 2 plus a squared plus a. All right, we got to simplify that. So we've got a squared plus 3a minus 2 over 2a squared. Now you take a look at that, and you ask yourself, can you factor it? And the answer is no, you can't factor that. That's as far as you can go, so you're done. Number 5. Okay, least common denominator first. Number part is 2. The a's, it's a cubed, and the b's, it's b cubed. So we need to multiply this first one by 2a over 2a, and the second one we need to multiply by just b squared. All right, so we've got 2a minus b squared over our common denominator, which is 2a cubed b cubed. And once again, that's as far as you can go. There's no factoring that can be done. You cannot cancel out those a's. You can't cancel out those b's. You can't cancel out those 2's. The reason why is because on top here, you're subtracting these 2 terms. You have to have just one big term that has to be factored in order to do that, and you can't do it. So don't do it, because I said so. All right, some more of these. A couple more monomials, and then we're going to get to the real hard ones down the bottom. Okay? So, number 1. Got to find the common denominator. 6 for the numbers part. Their biggest exponent with the a's is 2. And for the b's, it's also 2. So 6a squared, b squared. So this first one, we just got to multiply by b squared over b squared. The second one, we got to multiply by 2a squared. And the third one, we got to multiply by 6ab. Perfect. So we know we've got a 6a squared b squared on our bottom. And on top, we've got 1 times b squared is b squared, plus 1 times 2a squared is 2a squared, minus 2 times 6ab, which is minus 12ab. So, we can write this out. Let's see if we can do any factoring with it. You're not going to be able to do any factoring with it. There's no way. So you can't factor it anymore. You always try to factor at the end, but if you can't, just leave it. All right. Number 2. So this actually is a sneaky adding and subtracting fractions problem. Remember that this c to the negative 1 is by itself. And remember that this negative 1 only works on that d because there's no parentheses. So we've got 2d. That's a bad d. I'm going to write this over on the side. 2d over c plus 2c over d. Okay, so our common denominator is cd. So we need to multiply the first one by d, the second one by c. So we have 2d squared plus 2c squared over cd. All right. Now, you might look at this and say, like, oh, they're 2 perfect squares. Well, they're actually not perfect squares for a couple reasons. 1, 2 is not a perfect square. Okay, if it was 4d squared and 4c squared, then we're a little closer. It still wouldn't work because you're adding in between them, not subtracting. That's as far as you can go. Now, number 3, we've got 3xy as our common denominator. So we're multiplying by 1xy. We've got 3xy on the bottom and 2 minus x minus y on top. Can't do anything with that. Nothing you can simplify. No like terms, no factoring. Is there no factoring? Yeah, no factoring. Definitely no factoring. Okay, cool. That's it. Now, number 4. All right, this is when it gets tricky. This is exciting. Okay, so we have to find the least common denominator for these two. All right, what's hard about this is we now have this y squared plus 1, okay? So remember, we have to multiply this and this together in order to get our least common denominator, okay? It's actually y times this, okay? And I'll show you in the next problems that factoring these is always a good place to start. You always want, when you have polynomials in your denominator, you always want to factor them first because it makes the common denominator easier to find. But when in doubt, you multiply this, all of your denominators together, and you know you can always get a common denominator. So for this one, we've got y times y squared plus 1 because we can't do anything else. So this first one we have to multiply by y over y, and the second one you have to multiply by y squared plus 1 over y squared plus 1. Okay, so for the first part, we're going to multiply just the top by that, and we're going to get 2y. In the second part, we're going to multiply 5. We're going to distribute that 5 to both of them, so it's not 2. I don't know why that 2 is there. 5y squared plus 5. All right, and it's all over y times y squared plus 1. I would always leave it in the factored form like that. All right, you could distribute that y in there, but it's just going to make it more complex and harder for you to see if you can cancel or not. All right, so you always want to see if you can do any canceling, any factoring on top. Let's just rewrite this so you can see it better. The 5y squared plus 2y plus 5. All right, so there's not anything that's going to work out here. So that's as far as we can go. Okay, So for number 5, right, we're trying to find the common denominator between b minus a and a minus b. Now you could, of course, multiply those together. That's fine, and get a real big type of number, right? Or if we rewrite this one by distributing the negative out, right, it's going to be a over negative a minus b plus b over a minus b. Right, now these look like they have pretty much the same denominators. All that's changed is that negative, right? So remember that the negative can go with either the top or the bottom, so that negative could just go at the top. And so we have a really, really easy problem. It's just negative a plus b over a minus b. Okay? Now, you look at this answer, and you see, well, we might actually be able to do some canceling, right? If you distribute, once again, a negative out of the top, right, what's going to happen is those signs are going to flip, so we're going to get negative a minus b over a minus b. Right, now you can see the a minus b's can cancel, and the answer is just negative 1. Last problem here. This one's crazy hard. Okay, so we've got s squared minus s plus s squared minus 1. Remember when I said when you have polynomials down at the bottom, always factor them first. So let's factor both of them. They're both factorable. So we've got 5 over, pull an s out, s minus 1, plus 1 over s plus 1, s minus 1. Now we have a bunch of factors down here. So each of these factors just has to appear one time in our least common denominator. So we've got s and s minus 1 and an s plus 1. You don't have to do the s minus 1 twice. Okay, so our least common denominator here is going to be s times s plus 1 times s minus 1. Okay, so what we have to multiply by, this first one you just got to multiply by s plus 1 because it's already got the s and the s minus 1. And the second one you just have to multiply by s because it's already got the s plus 1 and the s minus 1. So our bottom looks like s times s plus 1 times s minus 1. And on top, we're going to have 5s plus 5 plus s, okay, which we can obviously combine to give us 6s plus 5 over s times s plus 1 times s minus 1. I don't know why s is in 5s should ever be in the same problem, but I'm sorry. 6s plus 5 over s times s plus 1, s minus 1. That's it.